Imagine eating a big steak dinner over 100 grams of protein in one sitting, and instead of shutting down your body's internal cleanup system, it keeps running. Meanwhile, you're building muscle and burning belly fat at the same time. For years, we've been told this is impossible. Protein spikes insulin. Insulin stops autophagy. You have to choose between building muscle or cleaning your cells. You can't have both. But what if that's not entirely true? A 2023 study from Maastricht University in the Netherlands discovered something that challenges everything we thought we knew about protein and fat loss. Now, before we go further, let me be clear. This isn't about eating unlimited protein without consequences. There are specific conditions where this works and specific situations where it doesn't. Today, we're going to break down exactly what happens inside your body when you eat more protein, why it may actually help you burn visceral belly fat, and most importantly, who this works for and who needs to be careful. This is educational content, not medical advice. If you have kidney issues or any health conditions, please talk to your doctor first. Let's start with the study that changed everything. In December 2023, a research team led by Dr. Jorn Trommelen at Maastricht University Medical Center published a study in Cell Reports Medicine that made waves in the nutrition science world. They called it the BBQ study because they wanted to test whether you could eat the amount of protein you'd typically consume at a barbecue, around 100 grams, and still benefit from it. Here's why this matters. For decades, fitness experts told us that your body can only use about 20 to 30 grams of protein per meal. Anything beyond that, they said, gets wasted or converted to sugar. So the advice was simple. Spread your protein into small meals throughout the day. But Trommelen's team suspected something was wrong with this advice. Previous studies only measured muscle protein synthesis for 4 to 6 hours after eating. What if they simply stopped measuring too early? So they tracked participants for a full 12 hours using advanced isotope tracer technology. They compared two groups, one that ate 25 grams of protein and another that ate 100 grams, both after a full body resistance workout. The results were remarkable. The group that ate 100 grams didn't just build more muscle. They continued building muscle for over 12 hours, showing muscle protein synthesis rates that were 30% higher than the 25-gram group. And here's what really surprised the researchers: less than 15% of the extra amino acids were wasted or burned as fuel, the so-called 30-gram limit. It was based on studies that simply stopped measuring too early. Your body can use far more protein than we thought. But here's where it gets really interesting. This study didn't just measure muscle building. They also looked at what was happening to the body's cleanup systems. And what they found challenges the old belief that protein completely shuts down autophagy. To understand why, we need to look at how protein and carbohydrates affect your body differently. When you eat carbohydrates, especially sugar or starchy foods, your blood glucose rises quickly. In response, your pancreas releases a large amount of insulin. Think of insulin as a broadcast signal that reaches almost every cell in your body. The message is clear. Energy is available. Stop cleaning up. Start storing. This insulin surge acts like a system-wide shutdown for autophagy. Your body shifts from cleanup mode to storage mode. Protein works differently. Yes, protein does raise insulin. But here's what most people don't realize. Protein raises insulin by roughly half as much as carbohydrates with the same calories. That's a significant difference. More importantly, protein activates specific sensors in your cells, not a broadcast signal to your entire body. The main sensor is called cestrin 2, which specifically detects leucine, the most important amino acid for muscle building. When cestrin 2 detects leucine, it activates the growth pathway in that specific tissue. The message from protein isn't store energy everywhere. It's repair and rebuild in targeted areas. But there's something else most people overlook. In real life, we rarely eat protein by itself. Protein plus carbohydrates, like chicken with rice, causes a much larger insulin spike than protein alone. Protein plus fat, like a fatty steak, slows down digestion and creates a more gradual insulin response. And lean protein by itself, like chicken breast, fish, or egg whites, causes the smallest insulin response. Let me give you a practical example. If you eat 150 grams of grilled chicken breast with a salad, your insulin rises moderately, and autophagy is only slightly affected in most tissues. But if you eat that same chicken breast with a large bowl of white rice, your insulin rises much more sharply, and autophagy decreases significantly throughout your body. This is why the type of meal matters, not just the protein content. Lean protein eaten without a lot of carbohydrates behaves very differently than protein eaten with bread, rice, or pasta. So protein by itself doesn't completely stop your body's cleanup systems. But what actually happens to all that protein you eat? Where does it go? This brings us to something the researchers call the muscle sponge effect, and understanding the specific conditions that make it work. After you digest, protein amino acids enter your bloodstream. From there, they can travel to your muscles, your liver, your fat tissue, or other organs. Here's the key point. If your muscles are hungry for amino acids, they absorb them very quickly, like a dry sponge dropped into water. When your muscles soak up amino acids that fast, your blood doesn't get flooded with nutrients. Your liver and fat tissue don't receive a strong nutrient signal. And because they don't sense excess nutrients, they can continue their normal cleanup processes. But this doesn't happen automatically. There are specific conditions required for the muscle sponge effect to work. The first and most important condition is exercise, specifically resistance training. When you lift weights or do resistance exercises, you create tiny tears in your muscle fibers. Your muscles need amino acids to repair this damage. After a workout, your muscles are primed to absorb amino acids at their highest rate. In the Maastricht study, all participants did a full-body resistance workout before eating their protein. This is crucial. The muscle sponge effect is strongest after exercise. The second condition is being in a fasted state. When you haven't eaten for 12 to 16 hours, your muscles are also in a nutrient-depleted state. They're ready to absorb amino acids. Protein consumed after an overnight fast or after intermittent fasting is absorbed more efficiently than protein eaten a few hours after your last meal. However, the fasted state alone is not as powerful as the post-exercise state. Combining both, eating protein after fasting and after exercise creates the strongest muscle sponge effect. The third condition is having low insulin levels. When insulin is high, your body is in storage mode. When insulin is low, your body is ready for repair mode. If you've just eaten a carbohydrate-rich meal and then eat protein shortly after, the muscle sponge effect is weakened because insulin is already elevated. Now let's talk about when the muscle sponge effect does not work well. If you eat protein right after a high-carb meal, insulin is already high, and your muscles aren't as receptive. If you eat protein without exercising and without being in a fasted state, your muscles don't have the same urgent need for amino acids. And if you're constantly snacking throughout the day, keeping insulin elevated, you never create the conditions for optimal protein absorption. Think of your muscles like a sponge. After exercise or after fasting, the sponge is dry and ready to absorb. But if the sponge is already wet from constant eating, pouring more water on it just causes overflow. This explains why when you eat protein matters almost as much as how much you eat. But here's where things get more complicated. This doesn't work the same way for everyone. Let's break down what happens in three different groups of people: those at a healthy weight, those carrying excess body fat, and older adults. For people at a healthy weight or who are lean, the biological situation is favorable. Insulin sensitivity is good, meaning your cells respond efficiently to insulin signals. Autophagy functions normally, and muscles respond well to protein intake. When someone in this group eats a high protein meal, especially after exercise, the muscle sponge effect works efficiently. Muscles absorb amino acids quickly. Autophagy continues in the liver and fat tissue because they don't sense a nutrient flood. This group can achieve what researchers call a dual state building muscle and maintaining cellular cleanup at the same time. For people in this category, the research supports eating around 1.6 to 2.2 grams of protein per kilogram of body weight per day. You can eat larger protein meals after workouts, 40 to 60 grams, without worrying about waste. Focus on lean protein sources to optimize the effect. For people who are overweight or obese, the situation is more complicated. Visceral fat, the deep fat that wraps around your internal organs, isn't just passive storage. It's metabolically active. It secretes inflammatory chemicals like TNF alpha and interleukin 6 into your bloodstream. These inflammatory signals interfere with your body's cleanup machinery. Here's what researchers found in people with obesity. The signals telling the body to start autophagy are actually elevated. On paper, it looks like their bodies are desperately trying to clean house. But when scientists measured autophagy flux, the actual rate of cellular cleanup, it was significantly reduced. The command to clean is being sent, but the machinery isn't responding. Imagine a car on a freezing winter morning. You turn the key. The starter clicks and clicks, but the engine won't start. That's what's happening with autophagy in someone carrying excess visceral fat. The ignition signal is there, but the system is jammed by inflammation. When someone in this group eats high protein, the muscle sponge effect may be reduced because of insulin resistance. Muscles don't absorb amino acids as efficiently. But here's the important part. Protein still offers significant benefits for this group just through different mechanisms. The thermic effect still burns extra calories during digestion. Satiety hormones still help reduce hunger. And protein still helps protect muscle mass during weight loss. For people carrying excess weight, the primary goal should be reducing visceral fat first. As that fat decreases, inflammation drops and autophagy function naturally improves. Aim for around 1.2 to 1.6 grams of protein per kilogram of your target body weight, not your current weight. Prioritize lean protein to keep total calories in check, and combine high protein intake with a modest caloric deficit. For older adults, typically those over 50, there's another factor to consider: anabolic resistance. As we age, our muscles become less responsive to the signals that trigger muscle building. The sestrin, two sensors that detect leucine, become less sensitive. It's like the volume on the signal has been turned down and you need a louder message to get the same response. Research shows that younger adults can maximize muscle protein synthesis with about 20 grams of high-quality protein containing roughly 1 to 2 grams of leucine. But older adults need approximately 40 grams of protein containing 3 or more grams of leucine to achieve the same effect. A 2012 study by Young and colleagues demonstrated this clearly. Young participants responded strongly to 20 grams of whey protein. Older participants needed double that amount to reach similar muscle protein synthesis rates. For older adults, the recommendations are different. aim for 1.2 to 1.6 grams of protein per kilogram of body weight per day, which is higher than the standard recommendation of zero point 0.8 grams. Distribute protein across 3 to 4 meals, with each meal containing 30 to 40 grams. Prioritize protein sources rich in leucine beef chicken, fish eggs, and whey protein, and combine protein intake with resistance exercise to increase muscle sensitivity. So we've seen how protein affects different groups of people. But there's another piece of the puzzle that most people overlook. Protein doesn't just build muscle. It actually helps you burn more calories just by eating it. This is called the thermic effect of food. When you eat, your body uses energy to digest, absorb, and process the nutrients. Not all calories are created equal in this regard. Some foods require more energy to process than others. Here's how the three macronutrients compare. Protein has a thermic effect of 20 to 30%. This means your body burns 20 to 30% of the calories from protein just to process it. Carbohydrates have a thermic effect of 5 to 10%. Fat has a thermic effect of 0 to 3%. Let me put this in concrete numbers. If you eat 1,000 calories from protein, your body keeps only about 700 to 800 usable calories. The rest is burned during digestion and processing. If you eat 1,000 calories from fat, your body keeps about 970 to 1,000 usable calories. That's a difference of 200 to 300 calories just from how your body processes the food. Over time, this adds up. If you increase your protein intake from 15% to 30% of your total calories, you automatically burn an extra 50 to 100 calories per day just from the thermic effect. Over a year, that's 18,000 to 36,000 extra calories burned, equivalent to roughly 2 to 4 kilograms of body fat. Why does protein have such a high thermic effect? Because amino acid chains are complex molecules. Your body needs many different enzymes to break them apart. Then it has to remove the nitrogen from amino acids through a process called deamination. Finally, it has to convert that nitrogen into urea to be excreted through your kidneys. All of these steps require energy. This is why high-protein diets can help with fat loss. But let me be clear, this is not magic. If you eat too many total calories, you will still gain weight regardless of how much protein you consume. Protein gives you an advantage in the math, but it doesn't give you a free pass to eat unlimited food. There's another way protein helps with fat loss, and it has nothing to do with calories or metabolism. It's about hunger. Many people fail at weight loss, not because they don't know what to eat, but because they're constantly hungry. Willpower has limits. Hormones do not. When you eat protein, your digestive system releases two important hormones, LP1 and PYY. GLP1, or glucagon-like peptide, one is released from your small intestine when food arrives. It slows down digestion, which makes you feel full longer. Here's an interesting fact, LP1 is exactly the hormone that weight loss medications like Ozempic and Wegovy target. These drugs work by mimicking GLP1's effects. But your body can produce this hormone naturally in response to protein. PYY, or peptide YY, is released from your large intestine. It sends signals to your brain saying you've had enough food. It reduces appetite and decreases cravings, especially for sweet foods. A 2013 study by Clow and colleagues tested this directly. They gave 8 healthy volunteers 3 different breakfasts on separate days: high protein, high carbohydrate, and high fat. All 3 breakfasts had the same calories. The results were clear. The high-protein breakfast produced the highest levels of both GLP-1 and PYY. The high-carbohydrate breakfast produced insulin levels more than double the high-protein breakfast, but lower satiety hormones. The high-fat breakfast fell somewhere in between. What does this mean practically? When you eat a high-protein meal, you naturally feel less hungry afterward. You eat less at your next meal without needing willpower to resist food. Your body's hormones do the work for you. This is why a high-protein breakfast is often recommended for people trying to lose weight. It sets up your hormones for the entire day. Now let's be honest about something important. I want to make sure we're being realistic here. Protein is a powerful tool, but it is not a miracle cure. Here's what protein can do. It protects your muscle mass when you're losing weight, which is crucial because losing muscle slows your metabolism. It increases the thermic effect of your diet, burning extra calories through digestion. It increases satiety hormones, reducing hunger naturally. And under the right conditions, it allows your body to continue cellular cleanup while still supporting muscle repair. Here's what protein cannot do. It cannot replace a caloric deficit for weight loss. It cannot burn fat if you're eating too many total calories. It cannot overcome a sedentary lifestyle. And it cannot replace adequate sleep or stress management. Here's an uncomfortable truth. If you're eating 2,500 calories per day and burning only 2,000, you will gain weight, even if 100% of those calories come from protein. The laws of energy balance still apply. Protein is one piece of a larger puzzle. You need caloric awareness, regular exercise, sufficient sleep, and stress management. Protein makes the journey easier by keeping you fuller and protecting your muscle, but it doesn't replace the journey itself. Let's talk about safety and practical recommendations. Based on current research, here are the evidence-based guidelines. For healthy adults, 1.6 to 2.2 grams of protein per kilogram of body weight per day is considered safe and effective for supporting muscle and metabolism. Going above 2.2 grams per kilogram provides minimal additional benefit for most people. Studies have not shown harm at 3 grams per kilogram in healthy individuals, but there's also no proven additional benefit. However, certain groups need to be more careful. If you have chronic kidney disease, high protein intake creates additional work for your kidneys. Please consult your doctor before significantly increasing protein. If you have a history of kidney stones, high intake of animal protein may increase your risk. Consider plant proteins or speak with a healthcare provider. If you have a history of eating disorders, focusing intensely on any single macronutrient can potentially trigger obsessive behaviors. Work with a healthcare professional if this applies to you. Let me give you a practical example of what a high-protein day might look like for someone weighing 70 kilograms who wants to consume around 120 to 140 grams of protein. For breakfast, you might have 3 whole eggs, which provides about 21 grams of protein, plus 100 grams of Greek yogurt for 10 grams and 1 slice of whole grain toast for 4 grams. That's roughly 35 grams of protein. For lunch, 150 grams of grilled chicken breast gives you about 45 grams of protein. Add a large salad with mixed greens, olive oil, and vegetables. For dinner, 150 grams of salmon provides about 35 grams of protein. Add a serving of quinoa for another 5 grams along with roasted vegetables. For a snack, you could have a 30-gram whey protein shake or 200 grams of cottage cheese, providing around 20 to 25 grams of protein. A few practical tips to keep in mind. Prioritize whole food protein sources over supplements when possible. Your body absorbs and uses nutrients from whole foods more effectively. Distribute your protein fairly evenly across meals, especially if you're over 50. This ensures you hit the leucine threshold at each meal to stimulate muscle protein synthesis. Drink plenty of water when eating high protein. Your kidneys need water to process and excrete the nitrogen from amino acids. Combine your protein intake with resistance training to maximize the benefits. Exercise makes your muscles more receptive to protein and enhances all the effects we've discussed. So let's bring everything together. The old belief that protein destroys autophagy and stops fat burning is incomplete. Science now shows that your body is far more intelligent than a simple on-off switch. When you eat protein, especially lean protein, especially after exercise or fasting, and especially when you're not flooding your system with carbohydrates, at the same time your muscles absorb those amino acids quickly. Your liver and fat tissue don't experience a nutrient flood, and cellular cleanup can continue in those tissues while your muscles repair and grow. For people at a healthy weight, this means you can eat bigger protein meals without worry. The 30-gram limit was based on studies that measured for too short a time. For people carrying extra belly fat, high protein can actually help, not because it's magic, but because it burns more calories during digestion, keeps you fuller longer through satiety hormones, and helps protect your muscle while you lose fat. As you reduce visceral fat, your body's cleanup systems will naturally start working better. For older adults, the research clearly supports eating more protein, not less. Your muscles need a stronger signal to respond, which means larger protein doses and more attention to leucine-rich sources. But let's keep this in perspective. Protein is a powerful tool, not a miracle cure. It works best when combined with smart eating, regular movement, adequate sleep, and respect for your body's limits. It makes the journey of getting healthier easier, but it doesn't replace the journey. Here's my question for you. After learning all this, what's one change you're thinking about making to your protein intake? I'd love to hear your thoughts in the comments. And if this information was helpful, consider subscribing. We break down the science of how your body actually works. No hype, no magic pills, just real information you can use. Thanks for watching. Until next time, take care of your body. It's the only one you've got.